Welcome to daily practice. In this video, I will explain you solution of the question that you can see on your screen. So for better understanding of each and every step involved in this solution, do watch this video till end. If you face any doubt, you can share it in the comment box or DM it on my Instagram handle. So without any further delay, let's start solving this question. Differentiate with respect to x. So we have to differentiate with respect to x. Sine inverse of under root of 1 plus x square divided by 2. So this is the standard inverse composite function that we have to differentiate with respect to x. Now as you can see that this is a inverse trigonometric composite function of sine inverse. So to differentiate such functions, there is a standard formula. What is that formula? Solution. We know the standard formula, that is d by dx sine inverse of f of x is f of x divided by under root of 1 minus f of x bracket. So the formula to differentiate sine inverse of f of x is f dash of x divided by 1 minus f of x bracket square. Now I will compare sine inverse of f of x with sine inverse of under root 1 plus x square divided by 2. Then what I will get? F of x is equal to under root of 1 plus x square divided by 2. Once we get f of x, I will differentiate this function of x with respect to x. Then what I will get? F dash of x is equal to 1 upon root 2 into 1 upon 2 root 1 plus x square multiplied by. Now I will multiply this derivative of under root of 1 plus x square with derivative of 1 plus x square, that is derivative of 1 with respect to x is 0 plus derivative of x square with respect to x is 2x. On further simplifying this, what I will get? F dash of x is equal to this 2x plus 0 will give me 2x divided by this 2 root 2 as it is into under root of 1 plus x square. Now this 2 will get cancelled. So what I will be left with? F dash of x is equal to x upon root 2 into under root of 1 plus x square. Put these values in the given formula, and after substitution, what I will get? D by dx sine inverse of under root of 1 plus x square divided by 2 is equal to f dash of x. F dash of x is x upon root 2 into under root of 1 plus x square divided by 1 minus f of x bracket square under root of 1 minus f of x. F of x is under root of 1 plus x square divided by 2 bracket raised to 2. So this square and square root will get cancelled. Then what I will be left with? X upon under root 2 into 1 plus x square divided by. Now as this root and this square will get cancelled, then I will be left with 1 plus x square divided by 2. So I will multiply this 2 with 1 in order to obtain common denominator. So what I will get? 2 minus 1 minus x square. This will give me under root of 1 minus x square. This whole term will be divided by under root of 2. Therefore d by dx sine inverse of under root 1 plus x square divided by 2 is, here you can see that this root 2 and root 2 will get cancelled. So what I will be left with? X divided by under root of 1 plus x square inside the bracket 1 minus x square. Now here I will use a plus b and a minus b formula. Then what I will get? X upon under root of 1 minus x raised to 4. As we cannot simplify this further, this is our final answer. I hope you have understood each and every step that I have used to solve this question. If you have understood the application of formula to differentiate standard inverse trigonometric composite functions, then give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. If you face any doubt, you can share it in the comment box or DM it on my Instagram handle. You can also try this question using theorem of derivatives of inverse function and share your feedback regarding the answer you obtained after using theorem of derivatives of inverse function and the answer that I have obtained. So that's it for this video. Differentiate with respect to x cos inverse of 1 minus x square. So we have to differentiate this inverse trigonometric composite function with respect to x. Now how to differentiate that? For that there is a standard formula, d by dx cos inverse of f of x is equal to minus 1 upon under root of 1 minus f of x bracket square multiplied by derivative of f of x, that is f dash of x, that is equal to minus f dash of x divided by under root of 1 minus f of x bracket square. So this is the formula that we have to use to solve this question. Now how to apply this formula, let me show you. Compare cos inverse of f of x with cos inverse of 1 minus x square. Then what we will get? F of x will be equal to 1 minus x square. Now I will differentiate this function of x with respect to x. Then what I will get? F dash of x is equal to derivative of 1 will be 0 and derivative of minus x square will be minus 2 into x. Therefore, on further simplifying, what I will get? F dash of x is equal to minus 2x. Now I have value of f dash of x, that is minus 2x, and value of f of x, that is 1 minus x square. So I will put these values in the formula. Therefore, d by dx cos inverse of 1 minus x square is equal to minus of f dash of x is minus 2x divided by under root of 1 minus f of x. F of x is 1 minus x square bracket square. In this way we have substituted the values of f of x and f dash of x. Now we will simplify this further. What I will get? This minus and minus will become plus, and this 2x as it is divided by this 1 minus, I will expand this. What I will get? 1 minus 2x square plus x raised to 4. On opening these brackets, what I will get? Under root of 1 minus 1 plus 2x square minus x raised to 4. This 1 and minus 1 will get cancelled, and I will take x square common from this 2x square minus x raised to 4. Then what I will get? 2x divided by under root x square into 2 minus x square, that is equal to this x square after coming out of root, it will become x under root of 2 minus x square. So this x will get cancelled, and what I will be left with? 2 upon under root of 2 minus x square. Now we cannot simplify this further, so this is our final answer for this given question. So in this way we differentiate the inverse trigonometric composite function using the standard formula. I hope you have understood the application of formula to find out the derivative of inverse trigonometric composite function. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe the channel and share your doubts in the comment box or DM it to me on my Instagram handle. I will explain the solution of the question that you can see on your screen. If you face any doubt, share it in the comment box or DM it to my Instagram handle. So without any further delay, let's start solving this question. Differentiate with respect to x cos cube cos inverse of x cube. So we have the composite function cos cube cos inverse of x cube, and we have to differentiate it with respect to x. Now how to differentiate this? Let's see. Solution. First, what I will do, I will assume the given function is y. So let y is equal to cos cube cos inverse of x cube. Now I will write this cos cube in this way. Cos inside the bracket cos inverse of x cube bracket cube. So I have written cos cube in this way using brackets. Therefore, this cos and cos inverse will get cancelled, and I will be left with x cube whole cube. Therefore, y is equal to x cube bracket cube will give me x raised to 3 3s are 9. I have used laws of indices over here. Which laws of indices that I have used here? Please tell me in the comment section. Now I have obtained y is equal to x raised to 9. This is the simplified form of the given function. So I will differentiate y with respect to x. Then what I will get? Differentiate with respect to x. Then what I will get? Dy by dx is equal to derivative of x raised to 9 is 9 x raised to 8. Therefore, final answer is d by dx cos cube cos inverse of x cube is 9x raised to 8. This is the final answer that we were looking for. So in this way, we differentiate the given function cos cube inside the bracket cos inverse of x cube. I hope you have understood each and every step that I have explained in this solution. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. If you face any doubt, you can share it in the comment box or DM it on my Instagram handle. Differentiate with respect to x. Now we have to differentiate the given inverse trigonometric composite function with respect to x. Now how to differentiate that? For that, we have a standard formula which is written as derivative of sine inverse of f of x is equal to 1 upon under root of 1 minus f of x bracket square multiplied by derivative of f of x, that is f dash of x. So on simplifying this, what I will get? F dash of x divided by under root of 1 minus f of x bracket square. So this is the formula that we will be using to solve this question. Now how to apply this formula? Let me show you. First, what I will do, I will compare the given inverse trigonometric composite function, which is sine inverse of f of x is equal to sine inverse of x raised to 3 by 2. So I will compare this sine inverse of f of x with sine inverse of x raised to 3 by 2. Then after comparison, what I will get? F of x is equal to x raised to 3 by 2. Now I will differentiate and find the value of f of x. Now I will differentiate f of x with respect to x and find the value of f dash of x, which is equal to derivative of x raised to 3 by 2 is 3 by 2 x raised to 3 by 2 minus 1, that is equal to 3 by 2 into x raised to 3 by 2 minus 1 will give me 1 upon 2. Therefore, the value of f dash of x is equal to 3 by 2 into x raised to 1 by 2. So in this way, I have the value of f of x and value of f dash of x. Now I can put the value of f of x and f dash of x in the above formula. Then what I will get? D by dx sine inverse of x raised to 3 by 2 is equal to f dash of x. F dash of x is 3 by 2 x raised to 1 by 2. 3 by 2 into x raised to 1 by 2 divided by under root of 1 minus f of x bracket square. So f of x is x raised to 3 by 2. X raised to 3 by 2 bracket square. That is equal to, now I will simplify this. What I will get? 3 upon 2 x raised to 1 by 2 divided by under root of 1 minus. Now here you can see that I will apply laws of indices. Then what I will get? 3 by 2 multiplied by 2. 3 by 2 multiplied by 2. What I will get? 2 will get cancelled and I will be left with 3. So x raised to 3. On further simplifying, what I will get? D by dx sine inverse of x raised to 3 by 2 is equal to 3 under root of x divided by 2 under root of 1 minus x cube, which is our required answer. I hope you have understood each and every step that is involved in the solution of this question. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe. I will explain the solution of the question that you can see on your screen. So I urge you to watch this video till end so that you will get complete understanding of each and every step involved in this solution. If you face any doubt during explanation, share it in the comment box or DM it to me on my Instagram handle. Without any further delay, let's start solving this question. Differentiate with respect to x. So we have to find the derivative of sine raised to 4 inside the bracket sine inverse of under root x with respect to x. Now how to find the derivative of this function? Let me show you. First I will assume the given function as y. So let y is equal to sine raised to 4 inside the bracket sine inverse of root x. Now I will write this sine raised to 4 as sine inside the bracket sine inverse of under root x, and I will raise this sine raised to 4 as sine of sine inverse under root of x bracket raised to 4. So in this way I have simplified this term. So what I will get? Here you can see that sine and sine inverse. So we know that sine of sine inverse of theta is equal to theta. So here theta is root x. So what I will get? Root x bracket raised to 4. Therefore y will be equal to x square. Now how I have obtained this x square from this term and which laws of indices I have used? Please share your answer in the comment box. Now once I have simplified this given composite function, then I will differentiate this with respect to x. Then what I will get? Differentiate with respect to x. Then what I will get? Dy by dx is equal to derivative of x square with respect to x will be 2x. Therefore d by dx of sine raised to 4 sine inverse of root x is equal to 2x, which is our final answer. I hope you have understood each and every step required to solve this question. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel. That's it for this video. See you in the next video. Till then, keep practicing.